We saw this application last time in the recorded video. A little fitness application that has two main dynamic pages on it. One page is a chart, and this is very similar to the chart that we created when we first studied PHP, where we got the squares of numbers. The calculation is a little more complicated than that, but the basic idea is the same. And the lecture talked about this. The other part that we have is the calculator, where we put in person's age, how many beats per 6 seconds were, and then you're told if they're in the optimal exercise heart range or not. I like to go over some of the key features of this application just as a review. Number one, the use of include files. All right. Include files, again, can contain any kind of code that can be in a PHP page. That is, it can contain HTML, it can contain CSS, it can contain JavaScript, it can contain PHP code. So it can contain any of that. And the idea is it's very similar to what we do when we create a CSS separate file. And that is that it allows us to share it between pages. So for example, in this example, we have a home page, a chart, a calculator, and a results page. All of them have the same basic look. All right. Now, if you don't use include files, like if you were doing this in CISS232, where all we knew was HTML, you'd have to like clone pages and copy and paste. And if you went and changed something in one of these sections, the header, the nav, or the footer, you'd have to go in and manually change it on all of these. Include files prevent that from happening. So for example, if we were to look at this, our homepage, index.php. It consists of HTML plus 3 PHP includes. The include for the header, the include for the nav, and the include for the footer. So we can go in and change that include file for the header, for example, or let's do it for the footer. Oh. Why is that? Oh, it's opening up in Visual Studio. Oh, I don't want that. We can change this footer. Zip file. Go to C:\. inetpub www root. That is the root directory. Remember, this has to, for this PHP to work, it has to be in the root directory. And for me, it's inetpub www root. So let me open the home page. And let me open footer. So this has copyright M. Zellers 2017, which means I initially created this example a little bit ago. Now, one thing to notice, by the way, is this special symbol here, $copy, semicolon. That actually makes the copyright symbol. There's a lot of HTML special characters, like if you need to show like British pound on your website, like if something cost, if you're doing a website for the UK, you could show that. Or like if you're doing mathematical expressions and so on, you could do that. So that's to do special characters, and you can look them up to see more. But if I want to change the footer, all I have to do is change it in one place. And it's not just changed on this page, it'll be changed on every page we go to. So use include files for common code. Even if I'm doing a project and I know it's going to use PHP somewhere, I generally make all my pages PHP. All right. And the reason I do that is because I can take advantage of include files. So we know it's a good thing to have our pages have a similar look. So therefore, include files facilitates that. So by all means, use them when you need to for like the main sections of the page. Then each individual page consists of the include files plus the stuff that is distinct to this particular page. Any of you taking CISS243 or have taken CISS243? Okay, I have the numbers memorized. I know not everyone does. This is the same thing that you get with the template page in ASP.NET with Razor pages. You have your main layout page, and then all you code is what's special to the specific page that you're doing. This is a different way to implement the same thing. So we have one place to change that. So I put the header there, the nav there, and the footer there. Then I still have my separate CSS file. All right. Second thing that I want to point out as review is let's look at the chart. Same thing with the chart. I have the includes. I have the stuff that's distinct for this page in its own section, and then I have the other include. But I have an include file for the calculations, and it's called heart inc. By the way, I've not updated this example, but it's actually better to not end your include files with an inc. That poses a small security risk for you. It's better to end them with a .php. So I've used inc here. When you do it, it's better to use PHP. All right, this heart include file contains all these functions that I'm going to use everywhere throughout my little mini application. Now, some observations about the functions. The functions don't do anything with the page itself. In other words, I don't have any prints on this page or echoes anywhere in these functions. Why don't I have those? Well, because we don't know what we're going to use the output for. We don't know how the page is going to format the particular output for these functions. Therefore, we leave the specifics of how the page is going to be formatted and how we're going to output the results of these functions. We leave that to the page itself. We don't do that in the include file. The include file is really self-contained. In other words, everything in a function gets passed to the file or gets passed to the function, and then we return the result. So we have several functions here. we have a function to calculate the maximum heart rate given person's age. And using the formula that I found online, there's other formulas to do this, so don't take this as solid medical advice. But the maximum heart rate for someone is 220 minus the person's age. So we take that, that's the maximum heart rate that you should have. Optimum heart rate that you should have is between half of that maximum and 80% of that maximum. So first we call this function to get the maximum, then we take 50% of it here and return it 80% of it here. So these functions take everything it needs to do its job from the arguments. It then does its job and then it returns the answer. Now, that's a sign of a good function when it does that. I wouldn't want, for example, these functions to access things on the page, like to pull a value from a form field, for example, because here in the chart, we don't have a form field. We're just looping through those numbers. So I wouldn't want, like, have it pull from the form like it does in the calculator page. All right. The page is going to link together these functions that are in the include file and supply the necessary data and do something with the results. Notice these functions are small. This is probably the biggest function, and my screen's a little set on a big font, but it really doesn't take much more than a page. It's good if you have functions that only take a page. Why? Because you can see them in one shot. Let's scale this down to a normal font size. Maybe that, or maybe that. It's a little small. We can get everything in this function basically on one page. We miss a few comments. That allows you to get your head around these things better. All right, so what does a chart do? Well, it loops through from age being 20 to age being less than or equal to 80. And it increments age by 5 each time. So we're going to do 20, 25, 30, 35, 40, 45, and so on. We then create our table. We have our table row. First TD contains the age. Second TD contains that message, which is the minimum exercise rate, a dash, and the maximum exercise rate. So if we look here, each TR has the age, it has the minimum, a dash, and the maximum exercise, then it has the absolute maximum heart rate. And we do that till we get higher than 80. So it does it from 20 to 40. It stops at 40, or it stops at 80. Questions on any of this? Now, why do we go to all this trouble of writing these functions? I could have written this where all the code was on this page, right? And it might have seemed more straightforward to do it that way than to create these functions. But the reason I created these functions is because I want to reuse the code. All right. It's the same. I want to do the same calculation. I want the calculations to be done the same way here on this page and also here on this page. Even though the output is very different and the input comes from different places. So in this case, the output is different. The output is just a message that says whether you're in the optimal heart rate range or not. This actually puts the range up here. So the output is different between those two pages, yet it uses the same functions. And that's a powerful thing. And to the greater degree that you can do that the better code that you're going to have, because it makes it easier to maintain. Let's say the American Heart Association comes up with a different rule for what your maximum heart rate is. All right. And you would just need to change it in one place, and that would be changed throughout the site. All right. So let's look at the calculator. The calculator, first of all, has both client and server-side validation. Now, in a real application, if I was doing this for real, I would have duplicated the client side and the server side validation. But here, the client side and server side validation are slightly different, if my memory serves. All I'm checking for on the client side is whether they've entered in an age or not. Whereas on the server side, I'm checking both the client, both the age and the number of beats. I'm also not checking on the client side, I don't think, if I enter in letters instead of a number. So if I was doing this, I would duplicate the validation both on the client and the server. Why do we do that? Why do we duplicate the validation on the client and the server? We do that because people can turn off JavaScript. All right. Now that doesn't really matter here in this one. Well, it doesn't matter as much. This isn't something critical, for example. But if you think about it, if all your validation was in JavaScript, for example, you could validate, a person could enter in an order, or a person could turn off JavaScript, enter in an order, and leave something out that was important, like a credit card number. All right. Now, if there was no validation on the server side, then you might have an order processed without a credit card number, and that's not a good thing for an organization. Now, as far as the credit card number goes, there will be validation both on the client and the server side, and the server side will do more extensive validation than the client. So the server side will go and actually contact the credit card company and determine whether it is a valid credit card number, determine if it's over the limit, determine if it's expired, and so on. But again, this being just for demonstration, I only validate the one thing on the client side, and I validate both things on the server side. Now let's take a look at a smaller example that does client-side validation. A real simple example that does client-side validation. All right. I think we had an example similar to this, where you put in hours and a job type, and then go to the page that processes the form data. Now, in a real application, this would be a PHP page that would actually do the calculation. I just kept it simple and just said, well, this page would be a PHP page and actually do the calculation. Let's see what kind of validation it does. It validates to make sure that hours are entered, and it validates to make sure that a job type was entered. If you enter hours, make sure that it's numeric. Oh, and it doesn't validate for over a certain amount. We probably should do that too. All right, so let's look at this. We're going to focus on the form one. This is all client side, so it doesn't have to be on the web server. I just want to like sort of define this formula for validating on the client side. What I have on the form is an onSubmit attribute that calls a JavaScript function. Now you have to be very clear on what is client-side code and what is server-side code. Any of these onSubmit or on key down or on key up, that's all going to be client-side code. So validate form is a JavaScript function. Now we'll look at the specifics of this in a minute here, but in general, the validate form does this. We have one giant function. It's going to assume the form is valid. It's simply easier to code it if you assume the form is valid, because all you have to do is find one problem with it. And if there's one problem with it, then the form is not valid. That's easier to code than the other way around, where you assume the form is invalid. Then you have to check and make sure everything is correct. It's easier to find one thing wrong than to validate everything being correct. So we're going to follow this formula. We're going to initialize be valid to true or whatever Boolean. We're going to have a series of tests. If it's not valid in the end, we're going to set our error message. And we're going to set our error message on the screen. A lot of students will use an alert box to display a validation error. That's generally distracting, and it causes the user to take another step. They have to close the alert, and you lose the message when you close the alert. So if you said you forgot to enter, email address and zip code, if you close that alert, a person's liable to forget. What were the two fields that I didn't enter? All right, so it's better to put the error messages right on the screen like I do in this case. Now, here's the key. When this is done, it's going to return either a true or a false. That's what return be valid is. We initialize be valid as true. We have our series of tests, and if any of these conditions are met, we know that the form is not valid. So this statement calls the function, gets the return value, then sends the return value to the onSubmit method. So we're going to send to the onSubmit method either a true or a false. And if it's true, it goes ahead and submits the page and calls this page, just like you would expect it to do. Oh, good. If it's false, it blocks the submission of the page. All right. So that's how the validation works. We have a function that returns true or false. We return that value to the onSubmit method, and that will either stop the form from being submitted or go ahead and submit it based on whether it's a false or a true. All right, now let's look at the files involved in this particular example. Calculator. Check range, INC. Check range, PHP. think that's it. So let's look at the calculator. The calculator follows that same formula that we had before. Whereas when the form is submitted, I'm going to call the page checkrange.php. And I'm going to send the data via the query string. On submit, return validate form. Well, again, how does this work? Well, just like we saw before, we're going to have a return value of either true or false. Now, again, in this case, we're only checking to make sure that there's something entered for age. Again, the reason I didn't do a thorough validation here is I wanted to demonstrate server-side validation, right? Because if they don't enter in beats per second, then this comes from the server. Whereas this validation error comes from the client. So I just make sure they've entered something in the age and I return be valid. Be valid is either going to return a true to the on submit event and it will go ahead and submit to check range, or it's going to return a false. So there's really nothing exciting with calculator.php. It could have been an HTML page, right? But I made it a PHP page so I could take advantage of the include files. Now you might ask, why is this validation not in an include file? Well, again, why do we put things in the include file? We put them in because we want to share them on different pages. In this case, this specific logic won't be shared on any other page. This specific logic is written for this page and this page only. So therefore, it can just be on this page. We don't need to create a separate include for that. So we're done with this page. We can focus on the results page. I forgot to open this one up. So let's look at the structure. Let's look at the structure of this check range page. First of all, it has these two includes in it: the heart inc and the check range inc. Again, to remind you, those should be heart PHP and something else.php. Don't use inc. Don't make the same mistake I did. All right. Now, check range inc, I'll admit, I went a little include file crazy. All right. This include file could really be part of this page because, again, I'm not sharing it anywhere else. So I could have put all this include file, all the functions in the include file in the check range PHP. So in check range inc, I'm not concerned about making it reusable because it's tied only to this particular page. So let's look what this does. Calling now a server-side function to validate the form. And if it's valid, I'm displaying the output. Well, validate form is in here, and it grabs values from the query string. Again, these functions are only on check range page. So I don't care about the rules I said for a good function before, about not pulling anything from the page itself. I make sure that they've entered an age. I make sure that they've entered a beats, that the age is numeric, and that the beats is numeric. And when I'm done, if I get any of these errors, I display an error message in a paragraph. And then that returns the be valid. So very similar to what we do on the client side. The difference is we've already submitted the form to the server, so we're not blocking the form from being submitted to the server. That's already been done. That's a done deal. So if it's valid, we display output. If it's not valid, we just display those error messages. So let's test if it's not valid. We enter a valid age, let's say, and forget the number of beats. We get that message, doesn't do any calculation. Now we look at display output. What does that do? It grabs the age and the beats again, and it calls a function in the heart include file in range. The very bottom of this, we have a function called in range that accepts the person's age, the number of beats, and how many seconds the number of beats were taken for. In our case, we're assuming 6 seconds because that's what the screen says. Enter your pulse for 6 seconds. We do a little bit of math to figure out how many beats per minute that translates to. We get the maximum exercise rate and the minimum exercise rate, and we check to see if the beats per minute are less than the minimum. If it's less than minimum, we return a -1. If it's greater than the maximum, we return a +1. If it's between the minimum and the maximum, we return a 0. So this function to display the output looks and sees and displays the appropriate message depending if this function returned a -1, a 0, or a 1. If it returns a -1, it says you're below the optimal heart beat range. If it's equal to 0, you're in, and if it's +1, you are above the optimal heart range. So we're using the same calculations. We're just formatting the output a little bit different on this page than we did in the other page. But at the core, the actual calculations are done via shared code, and that's important. Now you're going to have an assignment, or you already have the assignment of doing something similar to this with Loring Community College's tuition. Let me look it up. All right, create a mini site about LC, be a home page, a tuition calculator. All right, and then the next lab is to create the chart part of it. So before you write any code, think of what your functions are going to be. And when I wrote the heartbeat one, I thought, well, I need to know the minimum exercise heart rate. I need to know the maximum exercise heart rate, and I need to know the maximum heart rate, period. All of those are depend on the person's age. All right. So that's the argument, right? The argument in my functions are all going to be age because that's basis of the calculation. What is it going to return? It's going to return the heartbeat. It's going to return either the maximum heartbeat, the maximum exercise heartbeat, or the minimum exercise heartbeat, depending on which function I call. Now think about your case. Your case, what do you need to calculate tuition? So use this chart. What do you need to know to calculate tuition? Well, you need to know how many credit hours, and you need to know the residency status. If the person is an in-county resident, an out-of-county resident, or an out-of-state resident. So if you think about it, your arguments of your function, that's what you need to know to do the calculation. All right. What you need to know to do the calculation is another way of saying these are the arguments to the function, because you're going to pass in the arguments to the function. All right. And that's going to be the number of credit hours and the residency status. It's going to return then a dollar value for tuition. All right. Now, let's talk about the function itself. Because this might look straightforward, but there's a couple of hitches in the function itself. For 1 through 12 credit hours, you simply take the tuition for 1 credit hour for each of these and multiply by the number of credit hours. So for example, 3 credit hours for in-county is 492.09. That's simply 164.03 multiplied by 3. Okay. Check my math if you want, or just trust me, that's correct. We looked at 6 credit hours. 6 credit hours for out of state is 340 multiplied by 6. All right. That formula works from 1 through 12. At 13, though, we have a different formula. For 13 through 18 credit hours, you get charged the same as the fee for 13 credit hours. So it doesn't matter if you take 13 credit hours or 18 credit hours. You get charged 13 times the rate. And again, you use the rate depending on whether you're in county, out of county, or out of state. Finally, for 19 and above, you take the amount for 18 and add in the number of credit hours over 18 times the rate. So the formula for 19 is the fee for 13, all right, plus 1 credit hour times the rate. The fee for 22 is the same as the fee for 13 plus 4 credit hours times the rate. My suggestion, as always, and I can't emphasize this enough, and I know people don't always heed this advice, and I get it. you know, you're busy, you have a lot of things to do, you want to get these assignments knocked off. All right. So I used to work on the east side of Cleveland, and a lot of times when there was construction or snow, I would think I'm going to take a shortcut home. All right, instead of taking a normal route. Invariably, the shortcut took me longer. All right, just sticking with tried and true methods is the better way to do it. So take your time and do little pieces at a time. All right, before you go on to the next thing. If you were going to learn how to golf, all right, you wouldn't go out and just start trying to conquer an 18-hole golf course, right? You might go to a driving range and practice driving. Okay, you got that done. Then maybe practice irons, then go to a putt place and practice putting or whatever. So you do a little piece of it at a time. So write your function, create your function first of all to accept the residency code and a number of credit hours. Then your first pass through, you could just take the credit hours and multiply it by the rate for that particular student. In fact, type of student. In fact, if you want to do it even slower, you could just take the rate of 164.03 and multiply it by the rate. Now, that's not the finished product. That's your first pass. All right. So your first pass, you could not even pay attention to whether they're a resident or not. All right. And do the calculation and display the output. Then add, well, what if they're an out of county or out of state? Then add, what if it's 13 through 18? And then add, what if it's 19 and above? So do it in pieces. You don't have to get it perfect in your first stab. And try to do it little pieces at a time. All right. One thing I'm going to talk about next week is, if you notice, when I click calculator, on the calculator page, if I click calculate, it goes to another page. Well, that was a great example of what's wrong with that. I could have thought, I swear I entered a 31. You can't see your form because it takes you to a brand new page. We're going to combine the logic for the displaying of the form and the processing of the form into one page. That's called a postback. So we're going to do that next time in class, and then we'll see where we go from there. All right. Are there any questions at this point? All right, that's all I had for today. Have a good week. For those of you that take classes on Monday, next week, Monday's classes are canceled, not just for me, but for the whole campus in commemoration of Veterans Day. So if you have a Monday class, is canceled next week. Or actually, you should probably check Canvas to see what your teacher says, but the campus is going to be closed next week. Next week on Monday, that is.